I mentioned towards the end of our last tutorial that Expresso expressions can become exponentially bigger as you get more and more objects involved within them. That's about to happen here, because this expression is going to be considerably larger than any that we've tackled so far. And that being the case, I've decided to break it down into a number of tutorials and give it to you in bite-sized pieces, because I'm sure that will make it easier to take everything in. So let's just have a quick look at the object list here and we'll see where we are. As before, I've added a couple of spheres, as we can see up here, and I've given them the same expressions as the previous spheres. Once again, I've updated the values in the random seed nodes within the first expressions as need be. And in the second ones here, I've also gone in there and dragged in the operators from the range mapper nodes into the appropriate nodes within this expression. So that's all been taken care of, and if we press play, we now get 5 spheres randomly racing each other across the screen. So that's working nicely. So let's continue with this. If we go into our expression here, what we need to do at first is to copy all of this, all of these six nodes here. If we just command drag those down to copy, and we do the same again, that gets us the first little piece of this underway. We then need to connect our time nodes to the divide nodes here to get that sorted out. And then in our conditions, I'm just going to change the colors of those to red and blue respectively. So I'll just change that one to red, this one to blue, and that's got that done. It's another little bit of it on the way, and we now obviously need to change our yellow object nodes here. We need to drag in the red and the blue spheres to update those so that they've got the correct spheres in them. So we just drag our red into there and our blue into there. And that gives us the next part of our expression complete there. This is where things really start to get interesting. And as before, I'm just going to work with the green sphere initially, because this is complex stuff. So I'll start here. And the first thing I need are 4 logic compares, which are going to be, these are going to be less than. So what I'll do exactly the same as I did before. I'll set their operators or their functions to less than. Go into the title bar and change that to put less than in there. And then I'm going to copy these again because we need 4 this time instead of 2, because we've got the 2 extra spheres to compare. Put those down there, and then I'm going to copy all of these so that we've got those down there. In fact, what I'll do, I'll move all of them up a little bit because they're going to get in the way of that pink sphere there. So I'll just move these up to there. And these bottom 4 are going to be greater than. So I'll change their function to greater than. And put greater than in there. So that completes the first little part of it. As before, we need to look at booles. So we'll bring a boole in there, that's one there, and another one. And as previously, we'll connect these up. The boole's functions need to be set to AND, so we don't need to touch them. We'll put those 2 there, and then we'll copy those again. We'll put the other 2 down here. And wire those up in exactly the same way. I'm going to put a little bit of space between these, just to bring that down there. And then the next thing to do to finish this part of it off is actually to drag out another boole and connect both of these into it. The same thing applies here. So I'll put those 2 down there. Following on from here, as we did before, we need to connect the output of the condition for the green sphere to the top, or input ones, I should say, of all of the compares. So we'll do that and get that finished. Like that. And now it's a case of comparing each of the other spheres to being either less than or greater than the green sphere. So what I'll do is grab all of this, I think, and just drag it down so that we can get it nearer to the other spheres for now, so that we can show them all on the screen at the same time. So I'll put my pink into there, yellow into there, red and blue like that, and then repeat the process again, placing these into the compares that are looking at whether these spheres are greater than the green sphere in terms of their finishing positions. And that completes the wiring for this little part of the expression. So let's look at what we're doing so far. What we're saying is if the end figure or the end value coming out of this condition is less than all of these spheres, then the green sphere is the winner. So this is the winning scenario, or basically this means that the green sphere is first. Let's talk about it in terms of first, second, third, fourth and fifth. So we're first if this condition is satisfied. The second condition, if it's greater than, so if the end result here is greater than all of the others, then the green sphere has come fifth. So these are the first and fifth, or the winning and totally losing scenarios. That's what we're looking at with both of these. Because we're saying compare these two, if this and this are less than, if this and this are less than, and then we look at them collectively and say if all of them are less than. That's what we're doing with the Boolean here. Similarly with this, exactly the same deal. If this and this are greater than, this and this are greater than, and then the two collectively are both satisfied, then we know that we've come fifth there. We know we've come first here. That's exactly how that's working. So that's the first part of the expression complete. I'm just going to pause there because I'm going to label this up with remarks. So with our first two scenarios complete and now labelled so that we don't forget which way round they are, we can move on to our next scenario, and that's to check as to whether or not the green sphere has come fourth. So in order to do that, we need to start again with some booles. And this time they need a third input. So we'll start that with that one. We need 4 of these, so bring that one down there and then copy both of these as well, give us the 4. Just place those there. Now if the green sphere has come fourth, then it must be the case that its end result or its end value coming out of the output of the condition here is greater than a combination of any 3 of the remaining spheres. So we're going to describe those combinations by using the booles here. So we'll start by connecting the top one to the first input there, move down to our next one here, and down to our last one there. So that gives us our first combination of 3 that we can test against. The next combination, we'll start with the top one again. We'll miss out the second one this time, put the third one in, put the fourth one in. And for our third combination, start with the top one, put the second one in, and the fourth one, missing out the third. And then finally we'll miss out the top one, plug the second one in, the third one, and the fourth one. And that enables us to check for any four combinations of 3 spheres being or beating our green sphere to the end of the race. So that's that done. And to finish it off, we need to check some, because it could be that it's any one of those 4 combinations can be satisfied. So what we need to do now, grab another Boole, set its function to OR, because it's this or this or this or this that we're interested in looking at. Give it 2 more inputs, make it a little bigger, and then plug the outputs of each of the previous Booles into the 4 inputs like this. And that's our checksum. So that takes care of our coming 4th scenario. The final scenario that we're interested in is coming 2nd or 3rd. Well, really coming 2nd, because 3rd will take care of itself. We don't really have to look for that, but we'll look for coming 2nd. So if we copy these down, it looks exactly the same. What we need this time though, we need to check that any combination of 3 remaining spheres has been beaten by our sphere here, our green sphere. Because obviously, if we've beaten pink, yellow, red, for example, then we must have come 2nd. But we know that there's another 3 different combinations available. So exactly the same thing as before. We'll plug the output of the top one into there, second one there, third one in there, top one in here, miss out the second, third one in there, fourth one in there, top one, second one, miss out the third, plug in the fourth, and then finally miss out the top one and plug in the other 3. And that completes our 4 scenarios. I'll pause again and label those up. So that's the 4 scenarios complete and now labelled. As I mentioned earlier, we only need to check for 4 scenarios, even though there are 5 possible results, because the fact of the matter is that if none of these scenarios are true, then the only one that can be true is the 5th possible outcome, which in this case is the sphere coming in 3rd. That must be true if these are all false. It's as simple as that, so we don't have to look for it. It's already starting to look quite scary in terms of the wiring, but I'm hoping it's not too bad, having seen how I systematically put it together. It's just that there is a lot going on here, and it does start to become a real sort of rat's nest of wiring, and there's not really much you can do to avoid that. All I do is set things up in the most logical way possible, and certainly use remarks in order to remind myself as to exactly what's going on. I mean, one of the great things about this as well is if you click on anything, you can always see where the connections go, because it shows them in orange, and it's just a really good system and a good way of working, actually. So you can always remind yourself, and it's not too bad. But anyway, let's move on from here and see where we can take this expression next. Well, obviously, once we've got the 4 scenarios wired up and we know that any of them can be satisfied, we've got to work out what to do with them when they are satisfied. So what we have to do next is create a number of condition nodes. In fact, we need 5 altogether. And it's a little bit similar to what we did before. We'll get the first, get things underway, get the first one in. No, I've done it again, not compare, I want a condition. Okay, let's get a condition in there. So we have our first condition, and we're going to call this one our winning scenario. So this one we're going to say in here, I'm just going to go into the header there and put condition brackets first for that one. The next one we're interested in is going to be 5th. So I'm going to bring that in there and put 5th in there. Copy again. fourth, and again. And in this one, I'm going to put a second or third, because it can be either, this one. So we'll just make that a little bigger so that we can see what we're doing. So that's our four conditions set up there. And I've staggered them so that when I connect to them, I can see the wiring more clearly. These are effectively going to be nested conditions, what we call nested conditions. And the first one that we're interested in, of course, is the winning scenario. So if the output of this bool is true, we're going to use this one as our winning scenario and switch this one. So in this condition here, what I'm going to do is put in the parameter a number 4 in there. And you'll see why in a minute. It's similar to what we did in the previous tutorial. So if the condition is true, we'll switch and we'll be using the second input here. I'm going to plug that input from the fifth place condition, into the input 1 there. I can do this all the way through, so I'm going to plug that one into that one, and I'm going to plug that one into that one. The next scenario that we're interested in is whether or not we've come fifth. So we can take the output of this bool and plug it into the switch of our fifth condition there. And in here, I'm going to put 3. And as I said, I'll explain more in a moment. The fourth condition is the next that we're interested in. So we can take the output of this bool and plug it in there. So that's going to be 2 in the input there, or and then in the last condition, which is obviously second or third, we're going to plug that into there, and if we've come second, we're going to place a 1 in there, and then the input here, obviously we've got nothing in there, but as I said, if none of these conditions are satisfied, then a 0 will be passed from the input 1 here, which will snake its way through these nested conditions. You can see that we're actually doing exactly the same as we did with the first, second and third scenario. It's just that there's more of it. So it's a case of, if the sphere or the green sphere comes in first, this condition will be switched. All of these remaining conditions will be trumped. They will never get a further say in anything. Similarly, if this condition is not satisfied, but fifth is satisfied, this will be switched and these 2 will be trumped. If the green sphere comes fourth, this will be switched and the remaining condition will be trumped. If second is the outcome, then this input's used and the final input here is trumped. If none of the 4 conditions are satisfied, then this is the input that's used. So that's how that's going to work. The next stage is to bring in our fifth condition node. So let's bring that in now. And this is one, as before, this is the one that's a bit special. So we can place the switch from the output of the first one there. And this needs another 3 inputs. I'll just make it a little bigger. So we've got that there. Now in here, we need to change its, well, for a start, we need to change its data type to string, because again, we're going to be passing first, second, third, fourth and fifth on this occasion through there. So we'll change that to string. In the parameters, we know that the first condition here has a value of 4 in input 3, which means if the switch receives that value, we're using the last input. So again, we need to put first in there. Next condition, the fifth condition, or coming in fifth scenario, we've got a 3 in input 3 there. So we're looking at this input here, input 5 as it is there, that's going to be fifth. Moving on down, our condition for the fourth scenario, coming in fourth, we've got a 2. So again, we're going to be looking at input number 4 because we've switched to 2 there. So that's coming in fourth. Finally in here we know it's going to be 1 or 0. So if it's a true outcome, it will use the 1, which will use input 3. That's coming in second. And finally third is the last scenario of all. So it's out of sequence, but that's the way it works. So that's our 4 outcomes taken care of with regard to the position that the sphere finishes in. First, second, third, fourth, fifth. All taken care of here. The final part of the expression then is simply to bring in our text once again, our text spline for the green sphere. Come down to object properties, put text in there, place that there. And then finally, we do what we did before. We bring in a knot. Just place that about there. Bring in the green result. And select basic properties visible in editor. Make it a little bigger. Plug our knot into there. And then what I normally do here, because the expression's got bigger, I'll just drag the knot over there. Move that across there. Drag the knot a little bit further still. Just make sure I can get over to here. And then the output from the compare node, as before, needs to be plugged into the input of the knot. And then you can drag the knot back to its rightful place over here. This is one thing you can do when expressions get large. But anyway, so that completes the whole expression for dealing with the scenarios that can occur with the green sphere. Let's just run this and see what happens now. Make sure I've got it right, basically. So let's see. Yes, it came in last that time, and it did tell us it was last. Could be first. No, fifth again. Where are we going in this time? Still fifth. Still fifth. Third. Took a while to get third, didn't it? Third again. But I think it's pretty obvious that this is working fine. So even though we're seeing quite a lot of fifth scenarios at the moment, and I'm hoping we might, well, we got a fourth that time, well, we can see that there's a number of scenarios coming up. So it appears that the expression is doing exactly what I've set out to make it do, and it's working correctly. Now, obviously, the next thing to do from here is to copy all of this and wire all of our remaining spheres into this part of the algorithm. And that's exactly what I'm going to do now. So I'm going to pause and then we'll do a quick recap on what we've done. Okay, so that's our expression complete. And as you can see, it's become quite a monster now, and it's still not finished. But as we know, it's just the same things repeated another 4 times. So it's even though it looks horrendously complicated on the wiring now, it's exactly the same as what we did with the green sphere. There's absolutely no difference whatsoever to what's going on. The one thing I do want to mention is that if we just frame those and zoom in on them, one thing I'd done in my wisdom, I'd forgotten to wire this output here from the time node into the compare for the red condition here and the compare for the blue. So I was only able to display third, fourth and fifth results. It wasn't giving me a first and second result based upon what was going on here, because I wasn't getting the correct values from these, which was something that needed sorting out. And that's all done now. If we just scroll across to here, the only other things that need to be wired in and changed, when you copy this over, you need to wire the knot up to the appropriate compare. And the second thing, of course, you need to do, bring in the appropriate text spline for the sphere concerned, and of course the result, and bring that into there. They're the only things you need to really worry about on that score. Other than that, the wiring, all of this will remain the same. It's just the compares. Nothing will be plugged into the compares when you copy them. So whichever sphere you happen to be working on, they always go as before into the top, or input ones I should say, on the compares. So they're all the yellow in there. and the input 2s is just a case of systematically working through the remaining spheres as needs be. Obviously you'll plug the 4 of them into the top ones there in the less thans and repeat the process with the greater thans. It's as simple as that to wire that in. And it does look horrendously complicated, as I've said. It's just simply because, of course, there's a lot to it. But it's, as long as you follow those simple rules, you can easily wire that up. And it doesn't take too long before you become quite proficient at it. I mean, you're going to have to probably play around with the viewport here and maybe zoom in and stuff like that, and move things around in order to do it. But it's not particularly difficult, and it works at quite sort of high resolutions. You can still find that you can click on outputs and drag wires out from them even at quite high resolutions. It's not too bad to work with, and you can drag them over and then put them wherever they need to go. I'm not going to put that in there, but you can do it. Right, well, I suppose now we've got everything done to that stage, the best thing to do is drag this down here and let's see how it works. And it's pretty perfect, as you can see. It displays all our results quite nicely as they come in. Now originally I didn't think I was going to do much more than race 5 snakes and then display the winner of the race. But as so often happens, inspiration struck and I decided that it would be interesting to display their finishing positions. And then once I got it to this stage, I thought it might be quite nice if the text magically appeared and then shot up the screen, and depending on where the snake had come, so first would be the highest, or reach the highest point on the screen, and second slightly lower, and etc., with fifth reaching the lowest point. So this will be our next port of call with regard to the animation. But before we get there, we're going to turn spheres into snakes. So have fun playing around with this little piece of it, and I'll see you in the next tutorial.